So again, today we're going to go through these additional review problems. So these will be your binomials where you just cancel. You're going to see the factor and cancel questions. You're going to see multiplication, division, addition and subtraction of fractions, and two little word problems. But your word problems should not be difficult. Your setup is going to be the same exact that you're accustomed to. All right, so I'm going to start right on number 1 here. I'm going to write down your procedure that you're using with each of these two because I find that to be sometimes helpful. So your test is on Friday. And for question 1, we are looking at strategy. Okay, so letter A, am I allowed to start canceling or do I have to factor that first? So you have subtraction in between these terms. You are absolutely not allowed to cancel first. So next to this one, this is where you need to factor first. Do not go right to the cancellation. This is factor first. On the very top, what method is that going to be? GCF, good. I'm going to do a GCF for my numerator. So these are both divisible by 4, and they have n in them. And then I need to get another 4n out of this. So I'm just going to have to multiply it by 1 to keep that place. And then minus, and then 2n like this. And then over a 2n. Okay, so now you want to ask yourself, at this point, can you cancel? So are you allowed to cancel the n's? Yes, because now you've changed this so it's just multiplication. So now you can take an n from the top. You can do this really lightly in a different color so you can kind of see it. And then what else can I do here? How about divide by 2? So divide by 2, and then you're all said and done. So 4 divided by 2 gives me a 2. And then I'm left with 1 minus 2n. And then I am not left with anything on the bottom at all. So done. I'll just give you a lot of space on that. Okay, so that's as far as you need to go. You do not need to distribute that through. That's equivalent, so you can stop. So letter B, what is the first step I have to do with division? Yep, very good. I'm going to do keep, change, flip, and factor. I heard both. Excellent. This is a keep, change, flip. This does not involve a common denominator. So let's just write them out first. So you got plenty of space. So I'm going to go 4x squared and then minus 100 divided by trinomial, which would be x squared plus x minus 6. And I'm going to change it to multiplication. And I'm going to flip it. So we've got 2x squared minus 9x plus 10. And the bottom becomes 20 minus 4x. This is an example where you need to factor 4 separate times here. So the top is actually going to be a GCF first. I'm going to take my top numerator, GCF. Again, I have a feeling a lot of you would have thought that was dots, but you have to always do GCF first whenever that's applicable. This one's going to be a trinomial. So we take out the 4, and then I'm left with x squared minus 25. And then what can you do with it after that step? Dots. Yep, so I'm going to do this. Right underneath it, so you don't have to write it a ton of times. We're going to go x plus 5, and then x minus 5. Whenever you factor, you want to make sure that you are factoring completely. Okay, so that was dots now. So this is divided by trinomial. So this becomes multiplies to negative 6 adds to 1 would be plus 3 and minus 2. Now I come over to the next one. What method is my next numerator? AC. Yep, I'm going to use the space we had from question A. And then this one's the GCF. So I'm going to come over there, do the work, and then put it back in so you don't have to, again, keep writing it a million times. So I do 2 times 10. So 2 times 10 is going to give me 20. And I'm looking for two numbers that multiply to be 20 and add to -9. Excellent. -4 and -5. So those are what I'm going to place back in. So I take my 2x squared here. So I have 2x squared. And then minus the 4x, minus the 5x, and plus the 10. And straight down. So left-hand side, you're going to take out your GCF, which was 2x. And I'm left with x minus 2. Other side, I take out the -5. And then I get x minus 2. All right, so this becomes a 2x minus 5. And 1 copy of the repeated factor, which was x minus 2. So that comes up here. Almost done. And then x minus 2. Make sure you're copying your factors properly. I see a lot of mistakes get made there. And then your last one's your GCF. So you have 20 and you have a 4. So these are both divisible by 4. Yes, the order does matter. So 20 divided by 4 is 5, and that has to go first. You know it looks strange. And then you need the x. So now everything is factored as far as you can possibly go. So now you're going to very lightly cancel these, just in case you make an error, so you can go back and look at it. So I am able to remove x minus 2, x minus 2. Anyone see anything else? Yep, x minus 5 and 5 minus x. But when subtraction gets switched, what do we have to do? Good, -1. So I go 5 minus x with x minus 5. It's switched, so it gets that -1 at the top. I think you have one more thing. Your 4s. Yep, absolutely. 4s are gone. 4s are gone. And then answer. So what remains here is this -1. You can just do this if you'd like. And then I have the factor x plus 5. And then I have the factor 2x minus 5. And then on the very bottom, I have x plus 3. You do not need to take it any further than this. So that is an equivalent answer, and you're done. Okay, just a lot of heavy factoring with that one. And of course, that means you have questions too. But hopefully these are getting better too, because it is your 3rd day of review. So then I get on to letter C. Letter C is again going to be a case just like what we did, in which you have to factor first. So on the top, there's nothing that factors into, so I'm going to just simply recopy it. But on the bottom, what method's that one? Yes, very good, dots. So I'm going to go 3x plus 2y and 3x minus 2y. Some of these questions will be longer than others, so this one's relatively quick. If it's helpful, do this so that you know you can't split it up. You got to take the whole thing or none of it. And then in this case, I can cancel. So I have a repeated factor. So I'm going to take the 3x minus 2y, 3x minus 2y. But you have to be very much aware that the 3x plus 2y is left on the bottom. So because this is on the bottom, what has to get placed in your numerator? A 1. So that was left on the bottom, meaning we need a 1 to hold the place of the numerator. So done. Then some of them will be nice, quick, and easy. All right, so letter D, this is what we refer to as a complex fraction. These are the type where you might want to take something and cover up the bottom part like that. And then you're simply looking for a common denominator on the top. So I'm just looking at the 4 and the 4x and trying to find a common denominator for that first. So step 1, common denominator. So on the top here, what should we use for 4 and 4x? Yep, just 4x. Take the bigger of the two. So this first one has a 4. It needs to get multiplied by x. So x. The second one is all set up. So that one you just recopy the 1. Now you ignore that for a moment. You think about the bottom one. Again, cover up the top if that's helpful. This common denominator here is coincidentally also going to be 4x. Again, they don't have to be the same necessarily. My first fraction gets multiplied by 4. And my second fraction needs the x. Think of them as 2 separate parts. So 4 plus x. So there's step 1. So step 2, because this is a division problem, we're going to do keep change flip. So I'll come down here, keep it short and simple for you, keep change flip. And any of these little steps that you can write out, I can give you partial credit for if you get stuck. So if you know what the procedure is, but you make an error, still counts for something. So I have an x plus 1 over a 4x, and I'm going to change this to multiplication. And then I'm going to do 4x on top and 4 plus x on the bottom. This is the step where you would check these and see if they factor. In this case, nothing factors. So right there, not factorable. So can't do anything there. So your last and final step becomes to cancel. So third and last is cancellation. So in this case, we are able to remove a 4x and a 4x, and then you just copy your result. So we are left with x plus 1. Again, if it's helpful, do this, please, just because we don't ever want to split that up. And this one is 4 plus x. Okay, questions on anything on those first 4? Is everyone feeling fairly confident with those? Good. That's it on those. Now we move to your next. And you're looking to classify these as what category they fall into. So letter E, do we have binomials, trinomials, or monomials? Those are just single terms. So this one is just your case where you have the monomials, which is over here. You can, once you put these together, cancel immediately. So these are just monomials. Again, there is no common denominator necessary or factoring necessary. You could start canceling if you want, or you could put these together first. It doesn't make a difference. So if I combine them, I would have A and 3 A's here, which would be A to the 4th. I would have B to the 3rd on the top, and I would have C. So I just went right across. And on the bottom, I'm going to put it in alphabetical order. So I go A. I have 1 B. I have 5 C's and 7 D's. Again, all you have to do is cancel. That's it. So those are supposed to be the easy ones. So I am permitted to remove an A from the bottom and 1 A from the top, leaving me with 3 of those. Bless you. Now I take a B from the bottom, a B from the top, so I'm left with B squared. What else do we have here? Take a C from the top, C from the bottom, I have C to the 4th, and then your D's, there's nothing else you can do. Just make sure when you're canceling, you do it neatly so you can read what's left over. That also tends to be a problem. So my answer is A to the 3rd, B to the 2nd, divided by C to the 4th, and D to the 7th. Just like that, done. We feel okay with the monomials? Again, it's just a little cancellation when they look like that. Then we get to F. We haven't done one of these yet today. So letter F is addition. You look at the front whiteboard, what do we need for addition? Common denominator, very good. So this type's common denominator. Only for addition and subtraction, never for multiplication. So I'm going to take that first denominator and factor it using difference of two squares. So we go a plus 2, a minus 2. And when you get your common denominator, you want to use one of each factor. That's it. You don't need any more than that. So my denominators are going to be a plus 2, a minus 2, and then plus another a plus 2, a minus 2, and then another a plus 2, a minus 2. Is this the type where we can get rid of the denominator? No, very good. This is not an equation. There's no equal sign, so you can't cross that off. So now I look and see if we've got everything we need. So this first fraction has a plus 2 and it has a minus 2, meaning you don't have to multiply it by anything, and you simply recopy your a squared plus 1. Moving to my next one, it only has a minus 2. That means it's missing the a plus 2. So do that up here and then distribute. So I get 4a plus 8. Moving to the next one, I have the whole factor a plus 2. And this time it's missing a minus 2. Distribute, and I get 2a minus 4. Okay. At this part, and this is where I had some trouble yesterday. What you need to do with these is not refactor them. What you need to do is combine like terms in your numerator. Okay, so don't go back and factor it, otherwise you're back to where you started. You need to move forward, which means combine like terms. So the whole numerator. So I have a squared. 4a and 2a is 6a. I have 1 plus 8, which is 9, minus 4 is 5, over my denominator. Prior to canceling, you need to check if any of these expressions factor further. So is there anything I can do with that numerator? Yeah, exactly. She's right. I gotta do it. If it helps, great. If not, you just leave it. Now I'm going to factor trinomial method. This one's your try. Multiplies to 5 adds to 6 is going to be a plus 5, a plus 1, and then divided by my denominator, a plus 2, and a minus 2. So did that help at all? Unfortunately not, but you do have to take it to that step. Okay, so now it's fine. Nothing cancels, there's your answer. Leave it at that. All right, so all set. Letter G, we're looking for procedure. So what needs to be found for letter G here? Common denominator, excellent. So this is another subtraction problem in which you need a common denominator. So I'm going to take the bottom and I'm going to factor it into a plus 1 and a minus 1. And my common denominator is one of each factor. So I need the a plus 1 and the a minus 1. You just combine them together. So my denominator is a plus 1 and a minus 1. And then minus a plus 1, a minus 1. Multiply by what you're missing if anything. All right, so this one has the a plus 1 and it has the a minus 1, so it's all set. You just recopy the 3a plus 1 on the top. My second fraction has a plus 1 and it's missing a minus 1. So do this, distribute, a minus 1. These are the most frequently missed questions because students forget to do what with the negative? Distribute. So nice bold arrows on that, please, at this point. You've got to make sure you distribute. Otherwise, you're going to find that you get stuck. Nothing will factor from there. Very, very common mistake. So I get now 3a plus 1 from the left minus a plus 1 all over my denominator, which is a plus 1a minus 1. In my numerator, I need to combine like terms and then see if that helps me factor and go a little bit further. So in your numerator, I am going to be left with a 2a plus 2 divided by a plus 1a minus 1. And are we able to go any further? Yeah, exactly. Your top is going to GCF, which most likely is going to allow you to cancel a factor. So I take out a 2, I get a plus 1. And then this is divided by a plus 1a minus 1. And again, at the very, very last step, this is when you're permitted to cancel. So I'm allowed to cancel my a plus 1 because that's my repeated factor. And then what remains is your answer. So you have 2 divided by a minus 1. So final solution, 2 divided by, and then a minus 1. Everyone comfortable with that distribution of the negative? Okay. Again, I saw a lot of errors with that yesterday, which doesn't surprise me. It does tend to get overlooked sometimes, but that one definitely makes you look over tonight. That gets left off a lot. Letter H is your first example in which you have an equation. Equations have to be checked. So must check. It can just be, verbally or in your head, but you want to make sure that you do verify that your answers make sense. So this type, I need a common denominator first. X, 6, and 2, the smallest I could use would be 6x. The least common denominator, 6x, and then another 6x, and then another 6x. You're going to multiply by what is missing, and then on this case, you're permitted to drop the denominator. So first, I'm going to multiply by 6. That gives me 6. Next, I'm going to multiply that by x. So that gives me x squared. And lastly, I'm going to multiply this one by 3x. So this would give me 9x squared. Okay. Because you finally have an equal sign, you are permitted to drop the denominator. Only for equations. And then solve the numerator. So I have a 6 plus x squared equal to 9x squared. I'm going to shift my terms to the right-hand side so that this x squared stays positive. So move your 6 as well. So minus 6. All right, so we get 0 is equal to, I have 8x squared and minus 6. Okay, I'm going to take out a GCF from this. So these are both going to be divisible by 2. Yep, and then I get 4x squared minus 3. Then I just T-chart this. This one does work a little bit different than what you're accustomed to seeing, but just take it as far as you can go here. My 2 obviously drops off because 2 is not equal to 0. And then I'm going to go 4x squared minus 3 equals 0. Just like you would typically do. add your 3 over. I'm going to add my 3 over. And then I always want to isolate my x. So I divide both sides by 4. Just doesn't work out nicely. So I get x squared is equal to 3/4. And then how do I finish it? How do I get rid of the square root? Yep, I just do plus and minus, and then I just leave it at that. I get rid of the square root. I'm sorry, a squared by taking the square root. And I get x is equal to plus and minus the square root of 3. And then what happens with the square root of 4? What does that become? Just 2. And then your answer just gets left like this. Now we have to check it. So to do your check, you're going to take those values and pretend that you plug them in for x in your denominator. So right here, we want to make sure the denominator is not 0. So there's no way that would happen with this, so you're okay. So both of those are legitimate answers. It doesn't make the bottom 0, so you're good. And you can just leave it at that. How do we feel on those type? Okay. All right, the last thing we have are your word problems to do. I gave you one here that was multiple choice. Okay. So this has addition to it. You have the letters J, W, and F. So how do you find a common denominator in this case? You just combine them all together, just like you do with your factors. So common denominator is J, W, and F. So I write these out. So I've got J, W, F, plus another J, W, and F equal to a J, a W, and an F. Don't overcomplicate it. It's just 3 letters. You're looking for which ones you're missing. So in this case, I have the J. What does it need? Yeah, the W and the F. So you just do times WF. So 1 times WF is just W times F. The next one has the W. It needs the other 2, so it needs the J and the F. So I just do JF. And then the last one has the F. It needs the J and the W. This one needs J and W. Okay, so now it gets a little bit better. You are permitted to remove the denominator because this is an equation. So that's gone. And you're going to just solve the numerator, but it's just not going to be a numerical answer. So I have WF plus JF equal to JW. And what you wanted to find here is you want to get J. So it would be helpful to get both J's together. So you have J's on both sides. So let's bump this one over. And then just factor it out. So you have WF equal to JW minus JF. And then you're going to do the problems just like you're used to, where you're going to take out the GCF. So I take out a J, and I'm left with W minus F. And then your last step is to get J by itself. So how do you undo this multiplication? You just divide. That's it. And keep looking back at your answers too. You just want to make it look like that. So divide by W minus F. And then there you have it. So that one's done. So W minus F would be that. Because your multiplication, you could absolutely flip, so that's your commutative property. So just choice 3. It just works out with the algebraic notation instead of just getting like x equals a value. Last 2 are your word problems. All right, please don't overcomplicate these setups. So suppose one painter can paint an entire house in 12 hours. So we are accomplishing one task over the course of 12 hours. The second painter takes 8 hours. So how do I write the second painter? One house over the course of 8 hours, yeah. How long is it going to take them to paint the one house together? So 1 divided by X. Okay, so that's it. And then you just add them up. So I get 1 over 12 plus 1 over 8 is equal to 1 over X. You want to find the common denominator and solve. So you're looking for ideally the smallest number that 12 and 8 go into. So 12 doesn't work, so take the 12 and double it. How about 24? Does that work? Yes. So I'm going to go denominators of 24x. That's again what we call the least common denominator, smallest possible. Just makes your solving a little bit easier to get through. So I'm going to multiply the first fraction by 2x. I'm going to multiply the second fraction by 3x. And then the last one by 24. So we get a 5x equal to 24 when you remove the denominator and divide by 5. And it's fine with me if we just leave this. Sure, you guys can grab calculators. So x would be equal to 24 over 5, and that would be a rate in terms of hours. How's the word problem set up? I typically find that the word problems tend to be the easiest for students. So tend to really do good with those as long as you don't overcomplicate them. And then here's just one more of that type. You have one pipe that can fill one pool 1.25 times faster than a second. So we have 1 over 1.25 x versus the second 1 over just x. So your rates. When both pipes are open, they fill the pool in 5 hours. One pool, 5 hours. How long would it take them if only your slower pipe is used? So you're going to set up the same scenario. We're going to go 1 over 1.25x plus 1 over x is equal to 1 over 5. Okay, to get your denominator, what you want to do is multiply those numbers. So what is 5 times the 1.25? That'll get your denominator. So this is 6.25x. So 6.25x equal to 6.25x. Again, just multiply those together. The first fraction has to get multiplied by 5. Second fraction needs your 6.25. And there's that. And your last one needs the 1.25 and the x. Once again, you have an equation. You're going to drop the denominator, solve your numerator. So we are left with 11.25 is equal to 1.25x. And then divide by 1.25. Divide by 1.25. We've got 11.25 divided by 1.25. I got 9. So x would be equal to 9. It could ask you for both. And then if I sub back in 1.25 times 9, my faster one, 1.25 times 9. So this one would be 11.25. So how long would it take the slower pipe? This one's going to take longer, and that would be in hours. Okay, so this one's a little bit quicker. And again, if you want to label, this is in hours. How do we feel on those review problems? If you study those and you study everything that you did the last 2 days on Delta Math, you will be in excellent shape for your test. Okay, there's nothing else other than those. It looks just like this packet. Okay. You have no formal homework tonight other than to just study. And no homework over the weekend either.